Hello everyone, welcome to ITLS Academy. Today we are going to discuss the topic that is your titratable acidity and pH. So before starting the lecture, first of all, I just want to give a quick definition of this titratable acidity. Okay, so titratable acidity is the measurement of total amount of acid in solution. Okay, and this acid can be react with strong base strong base and neutralize. Okay, which means that when this when in a solution a total amount of acid are present and this acid are react with this strong base, then it will be neutralized. Then it is called what? It is called a titrable acidity. And pH, we all know that pH is simply a acidic or basic nature of food product. Okay, and it will from 0 to 14. Range of pH is from 0 to 14, where 7 is being a neutral. Okay, 7 pH is considered as a neutral. Okay, so this pH or what pH is measure how acidic and basic of substance or a solution. Basic, how acidic and basic solution. Okay, this is what? This is a pH, and the range of the pH are between 0 to 14. Now the next one, objective. Here we have to determine the titrable acidity and pH of a food sample. Okay, this is the objective of our experiment. Now principle. The volume of standard base used to titrate the organic acid in food to a phenolphthalein endpoint and can be used to determine the titrable acidity. Here, the principle of this experiment are what? The volume of standard base, okay, which is used to titrate the particular organic acid present in a food. Suppose that this is our food sample, and in this food sample, there is some organic acid like your A are present. Now, uh, now there is standard base are used standard base are used to titrate this organic acid which are already present into a food product. So volume of this standard base and phenolphthalein indicator are used as a endpoint, and after that we have to determine the titrable acidity of the food product. So this is the principle of this experiment. Now the chemical used in this experiment, first one is your ascaride. Okay, the first chemical which is used in this experiment are ascaride. Case number 81133-20-2, and the hazard related to ascaride is it is corrosive in nature. The second chemical is your ethanol. Case number 6417-5. This ethanol are highly flammable. Okay, so when we using this ethanol, we have to take a precaution. Okay, that we discuss in a hazard precaution and waste disposable slide. Now the next chemical is your phenolphthalein. Phenolphthalein case indicator is 77-09-8. The hazard related to this phenolphthalein is what? They are irritant in nature. The next one is your sodium hydroxide. This sodium hydroxide case number 131073-2, and they are what? They are corrosive in nature. So these are the list of the chemical which are used in this experiment. That is your ascaride, ethanol, phenolphthalein and sodium hydroxide, and along with it there is also mentioned hazard related to this chemical. Now the next slide is related to the reagents used in this experiment. So here the first reagent that we use is ascarite trap. Okay, so ascarite trap is prepared by putting this ascarite into a syringe, and this syringe are again attached to a flask in which CO2 free water are present. Okay, and how we prepare this carbon dioxide free water, it will it was already discussed in the previous lecture. You can go and see the video related to this. Even phenolphthalein indicator solution 1%. See how we prepare it. We take 1 gram of phenolphthalein and dissolve into 100 ml of ethanol. Okay, for this carbon dioxide free water preparation, you have to visit our previous lecture. Okay, now the next one is your sodium hydroxide and standard buffer of pH 4 and pH 7. Why we take two buffer solution? That's the pH 4 is for what? pH 4 is for acid and pH 7 is for neutral. So these are the reagent that is used in this experiment. Now the next one is your hazard precaution and waste disposal. We all know that when we are handling the chemical, so we have to take a care. So we have to follow a normal laboratory procedure. We have to wear a gloves, we have to wear a glasses, we have to wear a proper shoes, we have to wear a lab coat, and the waste which are come out due to this experiment, it should be discarded in a separate bin, and maybe it should be drained with the help of water. But when we are draining it with the help of water, we have to follow the good laboratory practices which come under the outline of environmental health, and along with it we have also followed the uh, protocol that our institution are given. Now see what is written in a slide. Adhere to our normal laboratory safety procedure. Wear our safety glasses at all time. Waste likely may be put down the drain using a water rinse, but follow good laboratory practices outlined by our environmental health and safety protocol at your institution. Now the next one is your material used in this experiment. We required apple juice, and the volume of apple juice is around 60 ml. Then we required a 3 beaker of 250 ml, 2 burette of 25 or 50 ml, 4 in a mere flask of 250 ml, and funnel which is small and it is easy to fit of top of 25 or 50 ml of burette. And along with it we are also required a graduated cylinder of 50 ml and soda, and this soda should be clear. That means that no extract, no foreign material or no extracted material are present in the soda, and the volume of soda is around 80 ml. And we also require two volumetric pipette, either of 10 ml or either of 20 ml. Okay, so here the sample are what sample food sample are apple juice and this soda. So we have a two sample in which we determine the titratable acidity and pH. Now the next one is your equipments. So here we required our two equipment. One is your hot plate and one is your pH meter. Okay, so this pH meter, when we using it it should be calibrated, and how we calibrate this pH meter, the video related to this experiment are already uploaded in our account. You can go and see the video of this experiment. Now the next one is your procedure. So first one, we have to follow the procedure for a soda. So we have prepared a tube duplicate for determining the unboiled soda or boiled soda. Okay, so we have take two sample of unboiled soda and two sample of boiled soda. Okay, so for it we have to open the soda well before use and allow the escape of carbon dioxide so that the sample can be pipetted. So when we open the soda bottle, then at that time the carbon dioxide are escape. So we have to allow to escape escape of carbon dioxide so that the sample can be easily pipetted. Now for unboiled soda, for this we have to take 20 ml of soda. This is our enamel flask, okay, of 250 ml. In this we add 20 ml of soda. Okay. Now after that we have to add 50 ml of carbon dioxide free 50 ml of carbon dioxide free water, deionized distilled water. Okay, then after that we have to add a drop of 1% phenolphthalein. Okay, and it is around 3 drops. Okay, now after that we titrate it with the standard NaOH, that is 0.1 normal of NaOH, and we dilute it until the pink color are faint. Then we have to record the beginning and ending volume on the burette, and after, with the help of this, we determine how much amount of NaOH is used during the titration. Okay, and one thing we have to observe, that is your end point. Okay, because color are fade. Okay, now the next one is your boiled soda. So in this case we have to take a 20 ml of soda again into a 250 ml of enamel flask. Now after that we have to boil it into a hot plate, and after boiling only for 30 to 60 seconds. Okay, this soda should be boiled only for 30 to 60 seconds, and then kept it at a room temperature for a cooling. Then after that again we had add 50 ml of carbon free deionized distilled water and 3 drops of this phenolphthalein indicator, and titrate it again. And same we have to measure the end point, and the end point is what? Faint of pink color. Now we have to record the beginning and the ending of the volume, and with the help of this we have to determine the volume of NaOH used during the titration, and observe the end point and note whether the color are fade. So this is about the soda. Now the next one is your apple juice. Okay, now sterilize pH meter with pH 7 and pH 4 buffer. Okay, so that means that we have to calibrate the, see, with the help of soda we find out the titratable acidity, and with the help of this apple juice we are going to determine the pH. Okay, now this standardized the pH meter, that we have to calibrate the pH meter, because if in every time when we are using the pH meter we have to calibrate it. So we calibrate this pH meter with the help of pH 7 or pH 4, and how we calibrate it is all the video related to this are already uploaded, you can go and check it. Now we have to prepare 3 apple juices sample. Okay, that will be compare A apple juice, okay, and B apple juice, that is and A apple juice are what, it is a original color, and B apple juice are titrated with the standard NaOH, and C apple juice are add phenolphthalein and then titrate with the standard NaOH. Okay, so we have a 3 apple juice sample. A is original color. Okay, B is titrated with NaOH, and C with after addition of phenolphthalein indicator, titrate, then after that titrate with NaOH. Okay, so after that we have to find out the pH. Now into each of 3, that is your ABC, we have to take 20 ml of apple juice, and into it we have to add 50 ml of carbon free water, same as it is. Okay, suppose that this is your enamel flask. So first of all we have to take 20 ml of this apple juice, then we have to add a 50 ml of carbon dioxide free water. Now in sample C we add 3 drop of 1% of phenolphthalein solution, that is C, and then we have to fill the NaOH into a burette and titrate sample B and sample C. A will not be titrated because we have to take a pH of A. Okay, so A should be in a original color. Here we only titrate sample B and C, and in sample B we are not adding the phenolphthalein, but in sample C we are adding. Now follow the pH during the titration of sample C containing phenolphthalein. Note if only one burette is available, then titrate B and titrate C sequentially. That is, add 1 ml to B and then 1 ml to C. Then you have to record the initial pH and pH at 1 ml interval until the pH reaches 9.0. Then after that you have to observe any color changes occur during the titration. Determine when the phenolphthalein endpoint is reached. Now you in sample A is indented to help you remember the original color of the apple juice, and sample P in which we are not adding the phenolphthalein does not need to be followed with the pH meter, but it to be titrated along with the other beaker to add observing the color changes. Now the next one is data and calculation. So the first table is for a soda. Here the first this is your burette start, then burette end. Then with the help of this you can calculate the volume of NaOH, that is burette start minus burette end. Then here a color fade, yes or no. Then this is your first one is your unboiled soda. Unboiled soda we take a 2 sample, and boiled soda we take a 2 sample, and with the help of this we take a mean of this. This is how we calculate the data for a soda. Now the next one is your sample calculation. Percentage of acid is equal to base titrate in ml multiplied by normality of base in mole divided by liter multiplied by equivalent weight of acid and divided by sample volume, which is in ml, multiplied by 10. Suppose that normality of NaOH is equal to 0.1019 normal, and base used in ml is 7 ml, and equivalent weight of citric acid is 64.04, and volume of the sample is 20 ml. When we put all the values into the formula, then we get 0.276% of citric acid. Now the next one is for a apple juice. Here it is for what? It is for a apple juice, that is our sample B. Okay, now in this case we have to observe the color change during the titration and color change during the end, and here we put all the values and see the pH will less than 9.0. This is how we calculate the apple juice, calculation for apple juice. Now after that we have to plot a graph between pH and ml of 0.1 normal of NaOH, but use the normality of your own NaOH. Okay, suppose that if you prepare 0.2 normal of NaOH, then you have to use it. Now pH will be on y-axis for the sample that contain phenolphthalein, that is your sample C, and interplot to find the volume of titrant at pH 8.8, the phenolphthalein endpoint, and with the help of this we have to calculate the titrable acidity of the apple juice as a percentage of malic acid, and the molecular weight of the malic acid is 134.09, and equivalent weight of malic acid is 67.04. So this is all about how we determine the titrable acidity and pH of the food sample. If you have any query, just let us know in a comment box, and for more detail you have to follow the ITLS Academy on different platforms like Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and subscribe ITLS Academy on YouTube and get our app from a Google Play. If you have any query, you can also ask to the helpline number that are already mentioned in your account, and you can visit our website, that is www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe. If you have any query, just let us know in a comment box.